Hello and welcome to this Swift programming video. My name is David Thorne. In this video I'm going to show you all about how to create files using the file manager at the beginning, and then as we move through I'm going to show you a little bit more of an advanced, more secure way of doing it, or an alternative way, a recommended way. So with that said, let's just jump straight into it. And I have actually just created this video and it decided to not save the file. Anyway, let's just create a file manager here and do default. And first of all, let's go ahead and show you how to create this. So with the file manager, we'll just say create file at path. And this myfile.txt is just created with inside this YouTube folder, which already exists. So we'll just say path 1. The data they're going to write to the file is going to be then data, and we're going to say data here, not dates. And we're going to say, hello world 1 here, and we'll just say UTF. And this will just return true if it's created it, false if it hasn't created it. As long as this YouTube folder has got right permissions to it, and this one user can write to this one file, this is going to get created and it's going to overwrite this one file every single time. All right, so we can just say here results, and if not a result, then we just can exit here, and we just say rather than get an exit code of 0, we get an exit code of 2, and we run this file, and you'll see here that we get, when it finishes, exit code of 0. All right, and we just run it again and we'll get an exit code of 0. So basically this is just going to keep creating that file and overwriting the file all the time. So if we come here and we cat out myfile.txt and we put then 2 at the end of it and we run this again, it's going to see myfile.txt. Okay, but let's open up this file now, right? And let's put hello world.3 and we run this once again. And you can still see we get here. However, you can see, warning, my file has changed since editing started, and so on. So you can see here that it's changed. And when we cat it out, it's 2 again, all right? Because we rewrote it back to 2. So it just goes to show you that even whilst we are reading from the file, right, that file has been opened, we can still write to it. So it doesn't mean to say that you aren't going to overwrite other people's work. And I might have come here and save and said hello world and wanted to say 20 or 2222, right? And I could be just about to do the write and quit function, and it says, look, okay, here. So we can get out of it, and we can now see that I've overwritten it. So this is the whole point of understanding that this is not safe, right? Because you might be creating or updating the file, but it's just not safe. And even by doing a fwrite, if is writable to this, yeah, you're checking is it writable, but that doesn't stop you from overwriting. It doesn't stop you from having a race condition with this, okay? So you can't stop another user on the system or another process on the system writing from this one file. So with that said, we have to think about how can we better open files without, well, how can we better open and create files? All right, this is the whole point of it, right? Okay, so in order to have a little bit more control over this, we've got to come down another level. File Manager is a super abstraction it's just a super abstraction. Okay, so let's just comment this out and let's just start thinking how else we can do this, right? So we've got something else called the file handle, and here we can see we've got file handle for reading from at a path, for writing at path, for updating at a path, file descriptor. This is the best one that we want to have, all right? Or file descriptor here is the best one we want to have. So right now we just want to write to at the path, right? So we're going to say path 1. And this is then going to return a file handle. So the thing is with this is that if this doesn't give us a handle, right, we can't do anything to it. So it adds that better level of checking, right? It's not the best level of checking, but adds another level of checking. So here we can say now write data. It says it's deprecated, but I don't care because at the moment I don't want to start adding if releases and this, that, and the other because of iOS or macOS 14, I don't care. All right, so now we can say here to write this data, and at the end of it, we can say then close file. All right. And when we run this, we should now see program exited with 0 still, and we should now see hello world 4 in the file. So let's just cat it out, and you can see here that this is now written hello world 4 to the file, but it didn't truncate the file. All right, so whereas create file would have just truncated it every single time, and so you've got to be a little bit more you've got to think a little bit more different now. All right, so we've got to see here. So we can first of all truncate. So truncates or extends the file by the factor whatever here, and then truncate the file at offset. So this is if we want to write over the file completely, right? We need to set the file back to 0 again and truncate it back to 0. So when we run this again, we should now see hello world 4. So we're saying set the file pointer back to the beginning and then overwrite everything. Okay. So this is how we can start doing it with then file handle. So the next way to go down another level as well is to use the C functions basically within inside of Swift. So the file handle, we just gave it a path, but what this is doing, this is getting a file descriptor and writing and opening and reading and writing to a file descriptor. So here we just say open, all right? And we come here and we say the path is path 1, and now we have to give the types of flags that we want to do it. And here we're going to say, create. So we want to create the file, right, if it doesn't exist already. And now what we are able to do is only create the file, right, if it doesn't exist. And this is then this O exclusive. So we are basically saying, hey, only do this create if it doesn't exist already. So let's try this and say if FD is equal to -1, this is then going to be a failure, and we're going to exit 2. Remember, we only care about the, let's just remove this. We only care about this exit at 0, right? Otherwise, this will exit down here. So now we need to close this file descriptor if we opened it, just to be, no, we need to close it, right? So when we run this, you'll see here we now get exit 2 because this file already exists, right? If we now do my file 1 and run this, you'll see exit with code 0. And then when we come and look at all the files inside of here, you'll see my file 1 with no permissions on here right now. So the next thing is that we need to check to see whether or not we have the right permissions. Let's remove this exclusive because let's just remove this exclusive. Okay, so now let's talk about the mode that we want to write to the file. And this is then done with these flags. So S underscore, and we want to come with an I. And in the beginning, we're going to say read, right? And we want to write and we want to execute for the user. So this is what the U means under the bottom, which is the mode underscore T. Okay, and we were basically saying only the user should be able to read, write, and execute on this one file. And if we want to give then other permissions to say to the group, reads for then the group, we can then say we're allowed the group to read it, and then we or in the other that say that they can read it as well. All right, so now we should have on the file, we should have something like this, and then we should have R dash dash R dash dash here. All right, so let's now try and create this one file. And we get program exited with 2 because the file already exists. All right. So let's just remove the file just to be fair on this and run this again. We can see now program exited with 0. And we can see now that we get RWX, R dash dash R dash dash. So we're getting the right permissions now here. Okay. Now, let's just try that again, and let's just try this once again, and we can see program ended with 0. So that was fine. There must have been something. I don't know why it did that. Anyway, so we now know that the myfile1.txt exists. I think it was because of the permissions. So when I created it the first time, I didn't have any permissions, and so I needed to delete it because it couldn't have written to the file. I needed to delete it as well. So that's more than likely what it was. So now we do have a file descriptor, and this means that we can write to this, we can write to this one file descriptor, and we don't need to test to see whether or not the file is existence or it's valid or whatever. If we've got a file descriptor, we definitely know that we can write to it because we haven't closed it up until now. Okay. Now, obviously, we still haven't solved the part about locking the file that someone else can read and write from it. But this is something that we're going to do in other videos. Okay, but for the time being, we're going to look at how we can go as low level as possible. Okay, so now that we've got a file descriptor, we want to be able to write to it. Now, to go into the next bit using the C write function, I think we need to open up another few other videos to be able to talk about that. So what we're going to do is we're going to say, fine, we don't want to use the file descriptor to write to it, but what we can do is we can create a handle once again, and we can say file handle this time for the file descriptor. And now this time it gives us an actual file handle. So we don't. So this here has done this checks here already for us, right? So this is what this check was. If it wasn't -1, it would have returned nil there. All right. So now we have this handle. We can use handle and we can write to the data of the file. So let's just copy the data here once again. And now we can write to the file, and we can come here and we can also say close the file down as well. And which means now we know that we've done everything that we need to do. And when we run this, we can see here that we're getting an error. It's because we don't have enough permissions, right? We are low level right now. Just because we've got a file handle, a file descriptor, doesn't mean to say that we can write to it, right? Even though we know that file is writable, because we said create it if it doesn't exist. But what we didn't do is we didn't give our file descriptor writing function, writing permission, right? And now by going we want write only, okay? We could have read only as well, or we could have read and write. So just because it's got an R on it, this doesn't mean write and read only. This means write only. And then if you want to write and read, that's the read and write here, okay? So it's kind of backwards. So write only. We need to give it the extra permission to be able to do this. And we run this once again. Program ended with exit code 0. And then when we cat out myfile1, you can see hello world 3, and let's just update it to 7, for example, and exited with 0, and we see hello world 7. So let's come here now and open this one file in Vim. Let's come to the end of it, and let's say this is some more text. Let's at least spell everything correctly. And now when we cat out our file, we say this is some more text. Let's now change this to 8, all right? And we run this once again. And then you might be a bit surprised about this, or if you know about this, you won't be surprised. Hello world 8, see, it overwrote the file, but there was still data after it. So if you want to be able to reset the file before you write to it, we're going to have to say here, we want to truncate file at offset 0. And you can see this is a deprecated warning, but we're staying with this here. So we're saying, hey, we want to remove everything, right? And remove everything at offset 0 all the way to the end of it. So it's just going to zero everything out, basically. We could say from 10, and then it would mean that it would just truncate everything from 10 upwards and so on. So we're just going to truncate everything. And let's just say from hello world 10 here. And when we run this, exit code 0, and now we get hello world 10. So this file.create file, this one here, this is basically, well, no, this is the next abstraction layer on open, but I didn't want to talk about write because it means talking about a few other things, and I wanted to try and keep it as simple as possible. But this is really the level of abstraction where you still get full control over it, right? But we could go even deeper. With that said, I hope that you got something out of this one video. Like, there's still a lot more to talk about to see whether or not this one file is actually on this one system. Is it a regular file? Is it a symbolic link? Is it a first in, first out file? Is it a stream? All of these things. These are things to think about. There's a big security level, whereas when you want to write to files and read to files, when working with lots of files, if you have a single process and you know that no one else can write or read to those files and only your process can, and there's no doubt about it, then using the file manager is perfectly fine. However, if you are saving sensitive data to that one file, and whilst you're writing to it, you don't want another process to be able to read from it or write to it to corrupt the data, you maybe don't want other files or other processes on other network devices to set symbolic links to folders that are on other systems. They could have first in, first out files where they're reading from it, and you write to that one file and you think, your process thinks, like myfile.txt, it could be there already, right? And it could be available to be written to with the right permissions. But this could be a first in, first out. It means that another server on the system is reading from this one file. And when you write data to it, it's gone, right? Because they've snatched it. Or it could be a symbolic link to another file system. So you've got to be really careful about when you create files. You know, today, unless your application is sandboxed, right? And you know, when you create a iPhone app or a macOS app and so on, they are literally, if you haven't configured it to do something else, they're already sandboxed to that one little area. But if you're writing executable files or binaries that want to be able to access files, or you've got to think about this at a really lower level, all right, for safety, for security, especially if you're dealing with sensitive data. With that said, I probably could go on a lot longer about this, and I probably will make other videos about this as well, because I think it's a really interesting topic. The thing to take away from this is don't use File Manager. That's it. Just if you're going to use, if you need to write to files, use File Handle, and if you want even more control over it, use open, close. But File Handle with the likes of stat and so on, to get the information about the file is definitely how you should do it. Try not to. File Manager is too much abstraction. There's too many calls there, and you're saving those system calls by just using these things instead. So write your own code. Try and write your own File Manager that uses the lowest level code as possible. With that said, don't forget to like, subscribe, share if you did like this content and you want to see more content. Otherwise, if you've got any questions, feedback, or concerns or critiques, then let's start a conversation in the comment section down below. Thank you very much for watching. My name's David Thorne, and I will see you in the next video. Ciao, ciao, and goodbye.